Okay, so I'm back now with the sixth mini lecture for this lecture from the week of November 16th to 20th on Science and Technology and Food, Module 6. Share my screen again. I ended off the last mini lecture 5 by talking about the regulations, the relatively permissive approach to regulation of genetically modified food in the US and Canada, where at least in the US, the main criteria is substantial equivalence to natural antecedents, and how that makes it a very easy environment for companies to receive approval for release of genetically modified transgenic foods compared to other places which are following more restrictive approaches, like as are described by the Cartagena Protocol, which countries have signed on to regulate the release of new genetically modified organisms of any kind in other countries, which following the precautionary principle puts the burden of proof on the importing agency or the company that wants to export to a new country. It puts a burden of proof on them to show that there is a scientific consensus that there will be no negative health or environmental effects. And I said that's had the effect of really dampening that type of development. And this golden rice case exemplifies this well. So this is a pretty famous case. I'll take you through. Golden rice was developed by these two Swiss scientists, Ingo Potrikas and Peter Bayer, to be a vitamin A rich rice. So it would be a rice that would naturally have a higher vitamin A content. And here's the cover of Time magazine from the year 2000, where it was claimed that this rice could save 1 million kids a year. But protesters believe such genetically modified foods are bad for us and our planet. Here's why. So just the background a little bit about vitamin A deficiency. It causes blindness, it impairs immune system function, increases risk of death from a variety of illnesses, viruses, and childhood, for example, childhood measles. Estimated that 124 million children have chronic vitamin A deficiency, and you can see the different levels of deficiency, very high in South Asia and much of Africa, where there's clinical levels of vitamin A deficiency. It's estimated by the World Bank and the Global Burden of Disease that vitamin A deficiency accounts for about 25% of the global burden of disease associated with malnutrition, and that there's 1 million kids, something like 2/3 of a million children die each year, and 350,000 kids go blind each year due to vitamin A deficiency. And this is numbers from the International Rice Research Institute. So it's a large micronutrient deficiency, which is common in developing countries, particularly countries in Africa. So we have a large challenge here of why people have low vitamin A content in their meals. One thing that could be done is people could have more diverse diets, and that's the main way that we get higher levels of vitamin A in, say, our diets here in Canada. But if that was very difficult for us for the same things we looked at for the kind of cost of healthy diets, one way around that is to actually breed higher levels of micronutrients into the crops that people are consuming for their calories. That was first, so research on that started by looking at, well, what is the mechanisms by which some plants have higher levels of vitamin A than others. And there was this discussion of this yellow endosperm, so the outer coating of foods, if that could be a pathway to enrich the vitamin A content of rice. The Rockefeller Foundation supported the first experiments of that, and in the year 2000, then those two scientists discovered that they could create a new rice variety that was transgenic, that took genes from daffodils, so a flower, as well as a bacterial gene, insert those into the rice genome, and generate something that has a yellow endosperm and therefore higher levels of vitamin A. For some years, that was developed in two big chemical companies. So Syngenta was the agricultural company that did the first research on this in the private sector. Fairly soon, there was this big upcry about golden rice. Lots of negative press about that, as hinted at in that Time magazine headline. People saw it as, on one hand, that companies like Monsanto or Syngenta would have this as a Trojan horse. So they would say, here's this cool new rice that you should have, and it's going to save 1 million kids a year. People saw that as just a way for Syngenta and Monsanto and other big companies to kind of sneak in and kind of capture markets in developing countries, and this idea of sort of the Trojan horse and sort of get everyone dependent on them. On the other hand, people are saying, if you're opposed to vitamin A rich rice, then you are doing the same as murdering children, that you have the blood of 1 million kids a year on your hands for opposing this. So this sort of the rhetoric ramps up very, very quickly in this around golden rice. In 2004 is when Syngenta stepped away because of sort of the very, very heated debates about this, and they weren't something that they may have thought that they were doing for humanitarian purposes, was quickly seen as something other than that. On the advantages side, it was seen as potentially saving and improving lives for millions of people. And on another advantage is really micronutrient enriched foods are the only ones which really being developed for poor people in mind. And at that time, golden rice is the only transgenic crop that was specifically designed with poor people in mind. As I said, other varieties being developed with conventional breeding, so like iron-rich crops are being developed now using conventional breeding. So you don't have to use a transgenic approach to get micronutrient content up, but that's what was done here. A disadvantage that was promoted by agencies like Greenpeace, and Greenpeace has really led the charge in opposing golden rice, is that there would be genetic drift from these golden varieties into other varieties. So you would kind of destroy especially for the kind of homelands of many rice varieties, you would get this kind of contamination from the golden varieties. That another disadvantage is that thinking that you could get all of your vitamin A from rice might prevent people from seeking other sources of vitamin A, like eating vegetables. And therefore, it might really not make if it changed behavior that way, it might not really make the problem better. An original controversy was you would have to eat a little mountain of rice every day to get your recommended daily intake. And of course, that's changed over time, but that was the initial content was lower. And again, it was seen as this Trojan horse, this strategy for a big agro industry to get into developing country markets. Since 2004, then, when Syngenta has dropped and backed away from this, they've given the rights to the genetic material to this thing called the Golden Rice Humanitarian Board, so try to make it into a non-profit international agency. There has been continued slow progress in developing varieties which are better suited to the Asian conditions, that have higher levels of beta carotene in them, which our bodies convert into vitamin A. We have something called golden rice too, which much higher levels of beta carotene, so you don't need to eat 3 kgs a day. Now is shown as early as 2012 that we were up to sort of a normal amount of a cup of rice a day would provide about 60% of the recommended dietary allowance of vitamin A. In 2018, Health Canada, and as well as the health officials for other countries like the United States, Australia, New Zealand have licensed golden rice. Partly we don't have any domestic rice production here. This Health Canada regulation says it's safe for consumption. Greenpeace still is opposing golden rice. It did in 2018, it still does now. There have been kind of a backlash in the science community against this opposition to golden rice. And as of January of this year, golden rice was approved for consumption or processing in the first country, which is the Philippines. Essentially, there's no farmers growing golden rice now. So this is showing how difficult it is, and this is in this context of the Cartagena Protocol, that countries that are importing or licensing GM food in their country for use in their country have to have this sort of overwhelming base of evidence, so there's not going to be any negative health or environmental effect, and that's very, very challenging. And there's a general challenge against then any of this breeding, and therefore we've got different paces of development in places like the US and Canada, and what we have in developing countries. So we've taken this overly cautious, maybe not overly, but this very cautious approach in most of the developing world, prompted and encouraged by agencies like Greenpeace, and we've taken quite a relatively permissive approach in Canada and the US, and there have been, the effects of that, and in a sense that's the negative possibilities are just catching up after kind of 40 years with this story about glyphosate. So this is my final slide for this whole set on science and technology in food and agriculture. First thing, and kind of back to kind of the ethics and economics, is privatize this. So I talked about privatization patents, the importance of patents to get the private sector to have an incentive to do innovation. Patents are a very important part of food and agriculture. And there is a large private sector investment in food and agriculture as a result. But it will only occur where the companies can really make profit. So if they can't see how they'll make a profit, then they're not going to invest in it. So they tend to then focus on things like hybrids or transgenics, where there's a clear, they can clearly control who buys it. They have a market for it year after year. Open traditional approaches to plant improvement, like are being done for breeding for micronutrients, have to be done by the public sector. Therefore, as is being done now in many African countries, support by the international community, but it's not because it's being geared for something that farmers can plant, and they take a seed and plant again. So the private sector approach seems not to work very well for poor places, which require more of a public sector approach. Countries that have established, as I said, the accepted substantial equivalence as their burden of proof or their level of proof certainly have much higher acceptance of GM foods. Very low in developing countries, but also in other countries. So Europe, China has become more skittish about GM foods more recently because of some backlash by their consumers, and consumers getting some of that kind of spillover from Europe. Certainly that glyphosate case is going to make people more skittish again. Consumers might be more skittish about GM foods, certainly about using glyphosate itself, especially at high levels. the ironic thing, depending upon that burden of proof, is that there really is no incentive. Once, say, a government like the United States that has approved the release of a transgenic crop would have to show a preponderance of evidence, or it would have to meet the burden of proof in order to counter that and show that there was a consensus of evidence that there was harm to people's health or people or the environment. So there's not really a strong motivation for governments to do that. Similarly, for poorer countries who might be importing transgenics from other places, they also don't have much incentive to invest to show the absent that there is very low risk to the environment or health for that import or importation. And therefore, we've got this kind of big investment by the private sector and very little investment, matching investment by the public sector. As the private sector is doing that, they're profit motivated, and in terms of what they release, people may suspect the credibility of the research that private companies do, but they may be the only ones doing it. So it's kind of a catch-22. Any review of the impacts of a technology which has been in place at some scale is to do an evaluation of that depends upon a credible counterfactual, what would have happened without the technology. So we have to think about would we have what different technology, say different herbicide control might be used? Would we be using more cultivation? All that has to be established. And overall in this area, we see that there is this highly contested nature of the knowledge about the impacts of the technology. So, and this is real consequences. So we've seen that $10 billion case, for example, with Bayer and case of glyphosate. Okay, so I'm going to end here. As I said, just one more short set of lectures on information technologies, kind of following up some of these same threads, but also developing some different threads. So thank you.